Question 1. We want to cancel out what's common on both the numerator and the denominator. To begin with, we can see that 48 is being divided by 16, which simply becomes 3. So we can just cancel it out. X to the power of 9 is divided by x to the power of 4, which simply gives us x to the power of 5, which means we can just cancel out the denominator side of x. Y to the power of 3 is common on both the numerator and the denominator, which means we can just cancel out both as well. Next, we have z to the power of 2 being divided by z to the power of 3. Z to the power of 2 is completely cancelled out, while z to the power of 3 has its power minus 2. We result with the equation 3x to the power of 5 divided by z. Next, for question 2, we have 2x divided by 5y, and this is all to the power of 3. What we first need to do is we need to bring the 3 to inside the bracket, and this affects everything, including the coefficients. So 2 to the power of 3, x to the power of 3, divided by 5 to the power of 3, and y to the power of 3. This simply expands out to 8x to the power of 3, divided by 125, y to the power of 3. Next, we have a combination of multiplication and division of pronumerals. What we want to do first is simplify both the numerator and the denominator, but separately. So if we look at the numerator first, we can see that there is a bracket of 3 minus 3a squared times b cubed or squared times 16a to the power of 8 times b. We want to expand the bracket first. This will give us 9a to the power of 4 and b to the power of 6 times 16a to the power of 8 times b. If we simplify further, we'll get 144a to the power of 12 and b to the power of 7. Next, we move on to the denominator, which is 2a to the power of 3 times b all cubed. If we expand this bracket out, we will end up with 8a to the power of 9, b to the power of 3. Now let's bring these numerator and denominator back together. We end up with 144 a to the power of 12, b to the power of 7, divided by 8a to the power of 9 and b to the power of 3. We can divide the coefficients and we'll end up with 18. When next we'll divide the a's, we end up with a to the power of 12 divided by a to the power of 9, which will just give us a to the power of 3. B to the power of 7 divided b to the power of 3 will just give us b to the power of 4. Moving on, we have quite a complex fraction. This includes both addition and multiplication within a division. So again, let's just simplify the top, which includes the multiplication signs, such that we have a single variable. So if we look for all the common variables first, so let's start with a's. So we have a n times a to the power of 3, which would just give us a to the power of 4. Next, we have b's, which is just b to the power of 3 times b to the power of 3, which just gives us b to the power of 6. Moving on to c, we have c squared times c squared, which is just c to the power of 4. Now in terms of coefficients, we just have 3 times 3, which is just 9. Now looking at the denominator, we can see that there is a common factor between each entity, and we can see that that common factor is just a squared times b squared. So let's just factor that out. After we factorize that out, we have a squared times b squared, bracket, 1 plus 3 plus 2, bracket. We can also see that on the numerator, we do also have a's and b's, which means we can just go ahead and cancel them out. We can cancel out the part of the 4 with the 2, and part of the 6 with the b squared. Additionally, the bracket on the bottom, as we can see, is just 1 plus 3 plus 2, which will end up being 6. So what we end up with is 9a squared b to the power 4 c to the power 4 divided by 6. 9 divided by 6 we know is 3 divided by 2, which means we will end up with 3a squared b to the power 4 and c to the power 4 divided by 2. Moving on to expanding brackets. If we recall the standard formula for expanding brackets, which is just FOIL. FOIL dictates the order of expansion. So if we remember the order of the variables within the brackets, we multiply the first of both, and then the outside of the pair, then the inside, and finally the last pair, which simply dictates the order of expansion. To start off with, we have first, which means we just multiply the first set of numbers within each bracket. This will give us x times x, which equals x squared. Next, we have outside, which will simply be x times minus 5 to give us minus 5x. Next, we have inside, which is the inside 2, which will be 3 and x. This will give us plus 3x. Next, we have the last pair of just 3 and 5. This will give us minus 15. Once we simplify the equation, we simply get x squared minus 2x minus 15. Moving on, we want to expand the brackets by multiplying what's on the outside by everything on the inside, such that 5a is multiplied by 3n minus b, while 4b is multiplied by 5n minus 7. One thing to remember is that with 4b, we must include the minus sign. When we expand this out, we end up with 15a minus 5ab minus 20b, and then plus 24ab. Have a look at what's similar. In this equation, we have ab, and that's it. So let's just simplify this equation to end up with 15a minus 20b and just plus 19ab. With a squared bracket, we simply have that bracket times by itself. This means that this bracket will actually be equivalent to 4x plus 1 times 4x plus 1. When we simply solve this equation, we use FOIL again. So if you remember correctly, it is just the first, which is just 4x times 4x to give us 16x squared. Next is the outer pair, which is 4x times 1 to give us 4x. Next is the inside pair, which is just 1 times 4x to give us 4x. Next, we have the last pair, which is just 1 times 1 to give us 1. Simplify this equation and we end up with 16x squared plus 8x plus 1. So again, we have a square bracket. which means we just multiply it by itself. So this is equivalent to y minus 3x times y minus 3x. So again, we want to multiply the first pair, which is just y times y, to give us y squared. Next, we multiply the outside pair, which is just y times minus 3x. This will just give us 3xy. Next, we have the inside pair, which is just minus 3x times y, to give us minus 3xy. Lastly, we have minus 3x times minus 3x to give us plus 9x squared. If we simplify this entire equation, we'll end up with y squared minus 6xy plus 9x squared. Moving on, we have a difference of two squares, which is y plus 3x times y minus 3x. For these types of equations, we just have to remember that we square the first one minus the square of the second one. So in this case, we have y squared minus 3x squared. This will just give us the answer of y squared minus 9x squared. Okay, so with factorizing, we simply take out what is common in each part and move it to the front. So as we can see with these four variables, the first two have a common 3 and an a. So let's just factorize that out first. So we'll take out 3a from 12ab, which becomes 4b, and then we have a minus 9a. If we take out a 3a from that, we're just left with minus 3. With the second pair, we have minus 15b plus 12. Let's just go ahead and take out the 3, which is common in both. There is no variable common, so we simply take out the coefficient. And remember that it is a minus 3, which means that the plus 12 will be divided by minus 3 to give us minus 4. And we'll just leave it at that. Moving on to algebraic fractions, we see that 2 divided by x minus 2 divided by x squared. So to begin with, we have to move them so that they have the same denominator. As we can see, the common variable in both is x. However, in the left one, there is missing an x multiple. So let's just multiply the first side with x divided by x. This will give us 2x over x squared minus 2 over x squared. Simplify this by simply putting them under the same denominator. Will give us 2x minus 2 divided by x squared. Moving on, we have 3 parts now. So if we look at the common denominator, we can note that each is a multiple of 10. So if we look at the first section, we note that to get 5 to 10, we simply times it by 2. So let's times the first part by 2 divided by 2. This will give us a base or denominator of 10. The top will become 6x minus 10 divided by 10. The second part we see has a denominator of 2. To get 2 to 10, we simply times it by 5. As such, we'll times the second part by 5 divided by 5. So 5x plus 2 divided by 2 times 5 divided by 5. This will give us 25x plus 10 divided by 10. The third part already has a denominator of 10, so we simply leave it as is without change. Note, however, that the minus sign has to be multiplied into the numerator. So simplifying these three parts, we have 6x minus 10 plus 25x plus 10 minus x plus 5. Note that in the minus 5 from the third part becomes a plus 5 because it's a minus times a minus. And that is just all over 10. Simplify a bit further, we have 6x plus 25x minus x to give us 30x. In terms of the constants, we have minus 10 plus 5 to give us plus 5. And this is all divided by 10. We can see that there is a factor of 5 common in the numerator and the denominator. So let's just cancel those 5's out. So we get 5 times 6x plus 1 over 5 times 2. We'll just cancel out those 5's. And what we're left with is 6x plus 1 over 2. Now this pronumeral or set of pronumerals seems a bit complicated, so what we'll work with is two parts. So the first part will be the first half or the top half, which is just 1 minus 1 over x plus 1. Let's just put that all under a common denominator first, which is just x plus 1. So we times the 1 on the left hand side with x plus 1 divided by x plus 1. And this will just give it a common denominator with the right hand side, which will lead us to x plus 1 minus 1 over x plus 1, which just results in x over x plus 1. Now let's look at the second half, which is 1 over x plus 1 over x plus 1. Now to put these two in a common denominator, we can't actually plus 1 to the denominator on the left. We do simply just cross multiply. This will give us a denominator of x times x plus 1. And the part on the left will equal to x plus 1. And the part on the right will give us x. So once we simplify this, we end up with 2x plus 1 over x and x plus 1. Now let's move this back into the original equation such that the top half is divided by the bottom half. We end up with x on x plus 1 divided by 2x plus 1 divided by x times x plus 1. We notice that in the second and fourth parts, we have a common x plus 1. So we'll just go ahead and cancel that out. This results in x divided by 1 divided by 2x plus 1 divided by x. Now let's refer to the method of a divided by b divided by c over d. What this actually equates to is a over b times d over c. Now if we put this into the pronumerals that we have x divided by 1 times x and 2x plus 1. What we end up with is x squared divided by 2x plus 1. Remember this method, as it is a very valuable method to remember, especially when using fractions of more than one denominator or numerator. Next, we have a sum of cubes. With a sum of cubes, we have to remember the formula, which basically states that we have the first part to the power of 3 plus the second part to the power of 3. The base in this equation is x and y. Next, we put it into the formula for a sum of cube, which is just x plus y, or the two bases added to each other, and then bracket again, the first part squared minus the first and second part times together, which is just minus xy, and then plus the square of the second part, which is just y squared. Okay, so we have another difference of cubes. So for this, we need to find the base of 729 and the base of 1301. So if we can just put that into our calculators, for the base of 729, we just get 9. So 9x, all to the power of 3, minus the base of 1331, which is just 11. So we just get 11y all squared. So similar to the first cube question, the difference is, however, that we do have a negative sign, which will end up shifting the sign in the final answer. So similar to the first part, we do have the base, which is just 9x, minus by the second part, which is just 11y, bracket, and then bracket again, the first part squared, which is just 81x squared, plus the multiplication of the first and second parts, which is just 9x times 11y. This just gives us minus 99xy, and then plus the second base squared, which will just give us 121y squared. So with this equation, we note that there is a common factor of x to the power of 3. So let's just go ahead and take out x to the power of 3. This leaves us with x to the power of 3, bracket x to the power of 3 plus y to the power of 3. From the bracket, we note that this is the same as the first question, and as such we can just write what was above into this part. So what we end up with is x to the power of 3 times x plus y times x squared minus xy plus y squared. Next we have a linear equation. So as you can see, the variable is just y. So we just need to solve it to get y. So first, let's just expand all the brackets we have, which we end up with 7 plus 3 times 3, which is 9, minus y times 3, which is minus 3y. This is equal to 4 minus 2 times 3 and times minus y. This gives us 4 minus 6 plus 2y. Next, we just move everything to opposite sides, so the y will be on the left side and the constants will be on the right side. So 7 plus 9 is 17, and we'll simply move the 4 minus 6 over to this side, so that we get minus 2 moved over. We flip the sign, so it's just plus 2, and then on the other side we have 2y. We'll move the minus 3y over. Again, we flip the sign, and we end up with 5y. Okay, so for this linear equation, as we can see, we must expand the brackets first, such that we end up with 7 plus 3 times 3, which is 9, minus 3 times y, which is just 3y. On the right hand side, we end up with 4 minus 2 times 3, which is minus 6, times minus 2 times minus y, which will just give us 2y. If we simplify both sides, we end up with 16 minus 3y is equal to 4, minus 6, which is just 2, and then plus 2y. Let's just move everything to one side so that we get 5y, and then the constants to the other side is equal to plus 14. Divide everything by 5, and we get an answer of y is equal to 14 over 5, or 2 4/5. Again, we want to expand the brackets first. So 3 times x, which is 3x, times 3 times minus 4, which is just minus 12. On the right hand side, we have minus 3x minus 12 plus x minus 5. Let's just simplify this again so that we have 3x minus 12 on the left hand side. There's no change. On the right hand side, we have minus 2x and minus 17. We'll move the x's to the left hand side and the constants to the right hand side again. We end up with 5x is equal to minus 5. Divide both sides by 5, and we end up with x is equal to minus 1. This time we have a pair of fractions. As such, we need to make it so that they have a common denominator, and in this case we can use the base 6. So the first pair, or the first part, we can actually take that and times it by 2 divided by 2. This will give us a base of 6, and hence 2x plus 6 over 6. The second half, we have x minus 4 divided by 2. We can change 2 to a 6 by timesing it by 3, and as such we'll times this part by 3 divided by 3. So again, times 3 divided by 3. We end up with a base of 6 and also 3x minus 12. Now let's just put this all back into the original equation, which will end up with 2x plus 6 minus 3x plus 12. Remember that the minus is on the outside of the second part, so when we bring it in, the minus 12 becomes a positive, and this is all divided by 6, and it's equal to a 2. The 6 on the bottom, we can just move that to the other side, so that is 2 times 6, we get 12. And we'll also simplify the numerator to get minus x plus 18 is equal to 12. Hence, minus x is equal to minus 6, and if we divide both sides by a minus 1, we'll get x is equal to 6. With quadratic equations, there are multiple methods of solving this. In this case, we'll be using the cross method, such that we find two variables that multiply each other to get the third or the constant, and then they plus together to give us the coefficient of bx. So in this scenario, let's just move everything to the left hand side. We end up with x squared plus 4x minus 5 is equal to 0. Now we look at the multiples of minus 5, and we'll get 1 and 5, and we also have x. So we need to add 1 and 5 in such a way that we end up with plus 4. Since 4 is the positive, then the larger constant on the cross has to be the positive, and the lower one has to be the negative. This just gives us plus 5 minus 1. Next, we bracket it such that it's x plus 5 times x minus 1, which is equal to 0. Next, for this equation to equal to 0, we know that one of the brackets must be equal to 0, and hence it's either x plus 5 is equal to 0 or x minus 1 is equal to 0. Now let's just solve both, and the plus 5 moves to the other side to be a minus 5. So x is equal to minus 5, or the minus 1 moves to the other side to give us 1, and therefore x just equals to minus 5 or 1. So again, let's use the cross method. So we have y and then a cross. And then looking at the constant, we need factors that will add together to give us minus 9. In this case, we'll have 8 and 1. And if they're both negatives, since it is a positive 8 constant, they both have to be negative. So we'll just have y minus 8 and y minus 1. And these are both equal to 0. And hence y is equal to 1 and 8. Moving on, if we want to find the exact solution of this equation, have a look at the right hand side on the denominator. We'll actually just move that to the left hand side by multiplication, so that we get x times x plus x minus 1, which is just equal to x plus 4. If we expand the bracket, we end up with x squared minus x, and we'll move the right hand side to the left hand side. We end up with minus x minus 4, which is just all equal to 0. Simplify this, we get x squared minus 2x minus 4 is equal to 0. If we look at the factors of the constant, there is no addition to get the coefficient of x, and as such we have to use a different method. So in this case, we will just simply use the quadratic equation. So minus b, which is just minus times minus 2 to give us 2, plus or minus square root b squared, and then minus 4ac, which is minus 4 times minus 4 times 1 divided by 2 times 1, or a. So simplifying this, we have 2 plus or minus square root 4 plus 16 divided by 2. So 2 plus minus square root 4 plus 16 divided by 2. Simplify the square root, we get root 20 over 2. Note that with root 20, we can actually simplify it by breaking it up into root 5 times root 4. And given that 4 is a square number, we can actually move that to the outside such that it's just 2 root 5. Now simplifying the equation, we have 2 plus or minus 2 root 5 over 2. We'll just cancel out the 2, which is common in every term, and we end up with the answer 1 plus or minus root 5.